We're putting the DJI Mini 4 Pro in front of the Windshaper and testing it in various turbulent conditions. Now, DJI drones have a reputation for being very stable, easy to use, and they just have great sensors all around to keep it steady in the air, even in harsh wind conditions. But can it stand a chance against the 6x6 Windshaper? Today, that's what we're gonna find out. We made some videos about the 6x6 Windshaper, but if you're not familiar with it, it's a wind wall that's made out of 6 fan modules in the vertical axis and 6 fan modules in the horizontal axis. So that's over 300 fans. And you can individually control these fans to create different kinds of turbulent flow, shear flow, gust. I asked my colleague Michele to write some scripts for the Windshaper so that we can test some different turbulent conditions. I also asked Lauren to fly the drone. She is, after all, a certified pilot. In this 3-part series, we'll be exploring the drone testing capabilities of the Windshaper and how the drone reacts to these conditions. In part 1, we'll be testing it in 3 different types of turbulence: gusts, checkered pattern, and a dynamic checkered pattern. So let's get started with the gusts.
All right, so for this one, I have a gust generated script. And basically what's gonna happen is gonna range between 30 to 50% of power. And we should see it run a sine wave pattern where it turns on and off and generates those gusts.
My prediction for this one, because the DJI drone has such good stabilization, I think once it gets into the turbulence, it's gonna almost just flutter. Like, I don't think it's gonna knock it off too much, but I think it's still gonna recover pretty well. I think it'll get knocked off position, but it's gonna come right back.
Right, yeah, I feel the same way.
Honestly, I wasn't expecting it to go all the way back. I was starting to get afraid it was gonna fly outside.
I know, we weren't expecting to have to use the net system today, but we almost did all that distance away. I guess it was a good idea to amp it up.
Yeah, and honestly, I'm really impressed with the drone's ability to correct itself after the first time. Then it started to finally settle itself back in.
Yeah, it was interesting. It was like the initial gust really destabilized it, but then once it got into position and got used to it, it really stayed steady the whole time.
Yeah.
It was like it found that angle that worked.
Apart from the concerning initial push of the drone, I would say this drone performed relatively well in this condition. So let's move on to the second type of turbulence, which are the checkered patterns.
So across the board, you're gonna see a couple squares of 4 modules. Each one of them are gonna be running at different speeds. So you have super fast, no speed, super fast, no speed, all across. I think this is gonna be very interesting.
My prediction for this one is that the drone is going to be sort of fluttering between the different spaces. And I think it's still going to stabilize well. It'll be that first set of gusts that destabilizes it the most. It'll get used to it and stay fairly stable.
I think we're also gonna see a lot more of the x-axis motion, where it's gonna be moving across those pockets. So we're gonna see a lot more of the back plus the side motion.
All right, let's see.
Oh no. Now this is the test where we added just a little bit of movement just to see what would happen, and yeah, it didn't turn out well at all. And just as a disclaimer, no drones or Windshapers were harmed in the making of this video, but it's just a bit of a concern when we try to add movement to the drone in these tests. But there's one more turbulence left, and that is the dynamic checkered pattern.
All right, so what's our final test?
I'd say for this one, we combine them both together.
All right.
For this checkered one pattern, we're gonna see it oscillating between the 2 different squares. So those that are normally off will change to on, and those that are on will change to off. So we'll constantly be shifting where the power is going to be located.
Okay, so there's no smooth area of air, at least not for very long.
That's it.
So the drone's constantly gonna be adjusting.
This one, I'm thinking we're gonna see that side to side. It has to.
Based on what we've seen so far, this is gonna be the most challenging test for the drone. I think we're gonna see movement in all directions. I think it's gonna be occupying a very wide area of operation. I just hope it doesn't crash into us or into the wall or the Windshaper, but I guess we'll see.
I was expecting to go flying maybe way outside of the view of where the wind shape was.
You didn't get your back and forth
I did
that you were
not
looking
get the
for.
side to side that I was looking for. I was really hoping that was gonna happen that time.
Even at the beginning, when it first started up, it was almost like it was ready. Do you think it's learning or something? Like it was
it's
in that
learned
tilted
since,
position.
right.
It's starting to know our games. Maybe that's what's going on.
One thing I did pick up on was that it had pulled itself towards the wind shape at one point.
It was compensating for the 100% winds, then it went down to 60,
Yeah.
kind of drew in because it still
Right.
had that power
Yeah,
setting.
yeah.
I mean, in summary, these were not the results we were expecting. And I guess that's why you have to run tests, because if you assume that you're gonna be right all the time and your drone's gonna perform in certain conditions the way you expect it to, turns out you're not always right.
No, I don't think it went exactly how we tested at all, or we thought it was gonna go in any way. We had these theories thinking we were gonna see specific motions, and it never happened at all. So, I mean, that's the reason why we run these tests in the first place, right?
Yeah.
In part 2, we'll be testing the drone in different turbulence intensities. And in part 3, we'll be testing the drone in shear conditions. So stay tuned for the next videos. And until then, thank you for watching.